All right, I want to prove this, and I'm going to say right off the bat that I use the word prove loosely. You gotta be pretty careful when you throw this prove word around, especially with regards to what I'm about to do. Um, I'm using an infinite series, okay? And technically, you want to be thorough. You need to use some analysis, real analysis business. You need to use limits, probably lim sup, lim inf. It's really advanced stuff. I'm not going to do it that way. So I'm gonna say sort of prove in quotes. I basically want to just give you an indication as to why this is true. Hopefully, this will convince you at least that it should be true, right? This is often known as Euler's equation, okay? And from this, you can get some interesting results relating e pi I negative 1, okay? I'm just going to use the series expansion, the power series for e, cosine, and sine. It's really not too crazy, but I just want to show you it's kind of cool, I guess, right? Let's do it. So we know, so e to the I theta is equal to the sum from k equals 0 to infinity. Okay, I'm using infinite sum. I already got to be careful. You can't just mess around with infinity, right? You usually need a limit, something like this, right? So this is I theta to the k divided by k factorial. Let's just write this out. Let's just write out the terms, okay? So this is equal to, this is I theta to the 0 over 0 factorial plus I theta to the 1 over 1 factorial plus I theta squared over 2 factorial plus I theta cubed over 3 factorial plus I theta to the 4th plus 4 factorial. Keep going however long as you want to be convinced. This is not too tricky to recognize the pattern here. Do what you know regarding the constant, well, the imaginary number I. I theta to the 0, that's 1. 0 factorial, that's 1 by definition. So this is 1 plus I theta plus, what is I squared? I squared is negative 1, so this is negative 1 theta squared over 2 factorial plus, what is I cubed? I cubed is negative I. This is negative I theta cubed divided by 3 factorial plus, what is I to the 4th? That's right, it's 1 because everything repeats after that, right? This is 1, so theta to the 4th over 4 factorial. The next term would be I to the 5th. What's I to the 5th? That's I. So I theta to the 5th over 5 factorial. Let's continue then. Let's rearrange things. Remember, the power series for cosine, 1 minus x, theta squared over 2 factorial plus theta to the 4th, 4 factorial. Look at the even powers. This is to the 0. This is even. This is even. Those are not going to have I involved. So I can absolutely write this as the following. This is equal to 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial. What would the next one be? Well, the one after this would be I to the 6. I to the 6 is negative 1 minus theta to the 6 over 6 factorial. Okay, plus, now let's group the I terms. So this is definitely dot dot dot. Okay, plus, if I group the I terms, it starts at, well, power of 1, power of 3, power of 5. That's exactly what the power series for sine does. There's only powers that are odd. Factor I out. Factor out an I. Left over. Theta minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial. keep going. The next one would be minus theta to the 7th over 7 factorial. This is absolutely the power series, k equals 0 to infinity of -1 to the k. Okay, it's alternating, so I need that factor of -1 there. And then theta to the 2k divided by 2k factorial plus, I factored out an I, and this is absolutely the power series expansion for sine. K equals 0 to infinity, -1, it's alternating, so I need the factor of -1 again. Theta to the 2k plus 1 divided by 2k plus 1 factorial. Alright, we're done. So this is equal to cosine theta plus I sine theta. Again, I mean, this is not a rigorous proof. Okay, if you're a math major, you know this is not rigorous. But it indicates that this is true. From this, the sort of, I think this is called basically Euler's identity, is that namely, what do we have? We have e to the I pi equals -1. Boy, oh boy, we're relating a real number, rational, -1, this common -1, not too hard to an integer actually to understand, with this weird exponential expression, excuse me, the natural exponential, along with I, imaginary number, along with pi. Irrational, imaginary, real. If you're not slightly impressed, if you don't think this is kind of cool, then you're not cool in my book. Not that my book means anything, but comment below. Tell me what you think.